Talking about the vertex form of absolute value equations, and vertex form is something we're going to be using the rest of the year. So this is an important lesson just to start to understand the basics of what we're doing with all our different values. So vertex form, y equals a times the absolute value of x minus h plus k. So our vertex form for every function is going to look something similar. And then because it is absolute value, our parent function is y equals the absolute value of x. So we have a, h, and k. If you look, you can see they go down in columns, so you kind of want to look at each in their column. So for a value, the a is our leading coefficient. So let me put that in blue. I don't know why it's white. But leading coefficient. And we say if a is positive, the graph opens up and has a minimum. So it'll look something like this. With the min, if it's negative, the graph opens down and has a max. So it would be something like this. If it's negative, it also has something called a reflection. It reflects across the x-axis, if I could spell. So we call it a reflection. So when talking about our a value, if the absolute value of a is greater than 1, the graph has a vertical stretch. Most of the time you'll just hear say stretches, but it is the vertical stretch. And if 0 is less than absolute value of a is less than 1, the graph has a vertical compression. Hopefully you can read. A vertical compression. So how that works, if we look, we always multiply your vertical movement by the value for a. So normally, in these equations, when x moves 1 to the right, y moves up 1. When it moves 2 to the right, it moves up 2. When it moves 3 left or right, it moves 3 up. But now, because of this, it's 6, we have to multiply our x times 6 to get our new y value. This is our new y. So we're multiplying our x value times 6. So you can see now, instead of just going up 1, it's going up 1 times 6. Instead of going up 2, it's going up 2 times 6. So it goes up quite a bit more. Let's look at our h value. The h is always the opposite sign of the inside value. And it's connected to the x in the equation. It's connected to the x, and a way to remember its opposite is think your x's lie. So just like in a dating relationship, your exes probably are lying to you. So it's a good way to remember. Our k value is our ending constant. It's on the outside. Sometimes it can be at the beginning if it's something that's then added to the absolute value, but usually it's written at the end. It's a constant, it's a single number. Our vertex, so hence the vertex form, is hk, taking the xy values. The h identifies the axis of symmetry. The axis of symmetry. So this basically, the axis of symmetry is x equals h. And the k value tells you, it tells the max or the min value. So now here is when we look at our vertex shifting. That's h's and k's. So remember, this one is opposite for h. So to move left, it would be x plus something on the inside. To move right, it would be x minus. Vertex shift for up and down, it stays the same. So up is plus k, down is minus k. So if we were looking at an example here, we have y minus 3. The absolute value of x minus 3. So our parent function, the absolute value of x, is going to look something like that. And we always want to draw our parent function first. Now, our new function, this shifts to the right 3 because it's opposite. 1, 2, 3. And it's going to do the same thing. So in this we'd say right 3 units. And then for the second example here, absolute value of x minus 3, draw our parent function, and then our new function is 3 down. So we would say down 3 units. So there's our front page of notes, just talking about the shifts, the stretches, the compressions, does it reflect, and what that all means. So now let's flip it over to some examples. So we'll go to the second page. So flip over your notes, and we're going to look at a couple of the examples. So this first one is y equals absolute value of x plus 2. So I'm going to draw the parent function first. That's just the regular function, and it has a slope of 1. It's always going to be v-shaped. So it's going to be a slope of 1 in each direction, and hopefully that looks close enough for you. Now as we look up here, this plus 2 is on the outside, so we'd say shift up 2 units. Because it's not inside the absolute value, you shift up 2, and it's going to go from there. The graph looks the same otherwise. So you shifted your vertex up 2 units. When I look at number 2, I'm going to draw in the parent function. And then as we look here, the minus 3 is on the inside. So that means we're going to shift right 3 because x's lie. We need to go opposite. Shift right 3 units. So that's when we start at 3, 0. It's going to look like that. And like that. So those are the first two. Now this third one, it's the negative out front. That means it reflects across the x-axis. And that's how you want to write it. Reflects across x-axis. So our parent function is still the same. But now our new function flips over. So it still starts at 0, 0, but now it's upside down. That's what reflecting across the x-axis means. this next one, you can see the 1/2 out front. That means it compresses. So you say compress by 1/2. So our normal one looks like this and like this. Our new one, remember now, it's going to go up 1 over 2, up 1 over 2. I'm going to try to connect, so I'm going up 1 over 2 in each direction. And I'm not doing a great job of putting the dots there, but I think you can see how it's flatter. All right, the very last question says y equals -3 times the absolute value of x plus 2 minus 1. So I'm going to put in our parent function here. And then we'll see what we need to do. So if we look, we have the minus. That reflects. Across x-axis. The 3 means stretch by 3. The 2 means left 2 because it's opposite on the inside. X's lie to you. So left 2, and then the -1 means down 1. So it's shifted. So if we look at where we're going to start at -2, -1, right there. And then we're going to go down. So down 3 and over 1. Down 3 over 1. Down 3 over 1. So we draw it on one side, and then the graph is going to look the same on the other side of the axis of symmetry. Because the axis of symmetry is right here, right where the vertex is at. This is our new axis of symmetry, that blue dotted line. So it's going to look, the graph is going to look the same on either side of that dotted line. And that is graphing by vertex form.